So example 2, given trig ratios in the quadrant of a particular rotation angle, find all the trig ratios for its corresponding reference angle. So last time what I gave you was a point. I gave you a coordinate, right? An x and a y coordinate. You solve for r, and then you could give me all the trig ratios. This time, they're giving you a trig ratio, and they're asking you for the other trig ratios. So whenever they do that, you do this, okay? So given trig ratio, ask for other trig ratios. So often, they'll ask for just one, not all the rest of the 5.
I printed off a lot of the notes, but I was late, so I had to just grab what I had.
Yeah.
Where is this? Is this like close? Because that's the beginning of my notes.
I missed the part from today.
Okay, so this is like tomorrow?
This is like one, I'm going to do one lesson today. Well, I'm recording. Yay. We're doing this today and then this in here. You're just missing everything. Just start writing. Okay.
So this, I'm not.
You're not there yet. So quadrant 1. So the very first thing, when they give you a trig ratio and they ask you for another trig ratio, the very first thing you want to do is draw a diagram. The reason why you want to draw a diagram is so that you get your x and y's correct, the signs, whether they're positive or negative. So it's in quadrant 1. We get ourselves a triangle. I know this one's going to be positive and this one's going to be positive because of the quadrant that it's in. That's why drawing the diagram is very important, because most people will mess up signs. Quadrant 1, you'd be okay, but other than that, you don't. Now, tan your x box. So we have y and we have x. We have 4 and we have 5. Now, often, they're not going to ask you, if they're asking you for one trig ratio, they're not going to ask you for cotan at this point, because cotan would just be it flipped. They're going to ask you for sine or cosine or secant or cosecant, because they're going to make you solve for the third side. They're going to make you solve for the missing one. Okay? So how do we do that? We solve for the third side by Pythagorean theorem. So step 1, draw the diagram. Step 2, solve for the third side. Step 3, give the ratio. Okay? That's the steps you're going to follow whenever they give you a ratio and they ask you for a new ratio. So r squared equals x squared plus y squared. So r squared equals 25 plus 16. So r squared equals 40, but we're going to take the square root of it. And because it's normally positive, negative, but because it's an r, it has to always be positive. Yep. 41. Yep. And then 41 you can't reduce because it's a prime number. So instead of finding all the ratios, I'm going to pick a ratio for you to find in the last box. Okay? So the ratio I want you to find is cos. You give me cos. And it's cos theta. If not, it's the word cos, which means nothing. You have to have that theta. And then it's x over r. So it's 5 over root 41. But then we want to rationalize the denominator, so root 41, root 41. So we get 5 root 41 over 41. So that's the easiest way it can be asked. It gives you the quadrant, you just draw it. This is the second easiest way it can be asked. It gives you the quadrant, it just doesn't say quadrant 2, right? It says between 90 and 180, which is quadrant 2. So that's the second way they can make it a little harder. So we're in quadrant 2. I know that this is going to be negative. This is going to be positive. I always put my signs right away so that I don't make a mistake and forget my signs, because that's often what the mistake is, and they'll have that answer on your diploma. I'll have that answer on your test. Wrong sign. Sign your resume. So we're given y, and we're given r, root 10. You have to solve for x. So it's going to be x squared equals r squared, which is root 10 squared, minus y squared. Remember, you have to rearrange it. So if it's x squared plus y squared equals r squared, if I'm solving for x, I have to subtract the y over, right? So I'm going to get x squared equals root 10 squared is just 10 minus 9. So x squared equals 1. Take the square root. When you take the square root, you get plus or minus. So x equals negative 1. And it's minus because we drew it here. Do you see if we don't draw it, you might often just take the plus of it, the positive, and then you're going to get it wrong. Or you're just going to guess the sign, which is problematic when you're guessing anything. I want you to give me cotan. Cotan theta. So tan is tan your x box, so y over x. Cotan is going to be x over y. It's just a flipped version, right? So it's negative 1 over 3. Or you could write that as negative 1 over 3. Or it could be written as 1 over negative 3. Any of those answers are correct. People are like, but the negative is on the 1, it's not on the 3. It doesn't matter. The negative can be on any of them as long as there's only one negative, right? So they can move it around. This would be how they would make it a little more tricky, right? The answer, yes, that is correct. But this is also correct if they move the negative down, even though it doesn't look like that on the diagram. Because the negative can move. So number 3 and 4 are the trickiest of them. So they just tell you tan is greater than 0. Whenever they say in this unit, tan or cotan or any of them is greater than 0, that means tan's positive. Instead of writing tan is positive, they'll write tan is greater than 0. Now people will say to me, but Mrs. Lepp, it's positive in 2 places because we use cast rule, right? So it's positive here, C-A-S-T. It's positive here and here. So it's positive in 1 and in quadrant 3. How the heck do we narrow it down to which quadrant? Negative on the fraction, and the fraction is sign. So it's where sign is negative. So where is sign negative but tan positive? Quadrant 3. Because tan's positive here, but sign is positive here. Tan is positive here, and sign is negative here. So it has to be in quadrant 3. A lot of the time, they put these trig ratios in quadrant 3. Because what they can do, even if they give you tan, they'll give you tan of like 3/4, let's say. And then you'll put it in as positive 3 and positive 4. But it's not positive 3 and positive 4. It's actually negative 3 and negative 4. But what happens when you divide two negatives? It becomes positive. The negative signs go away. So that's why they often give you tan in quadrant 3, because you'll put positives here because you won't draw the diagram, and you'll forget they're both negative actually because they're positive on the trig ratio, right? So that's the common one they give because they are both negative, but tan 3/4 is going to be both positive, but they actually were negative. The negative signs cancel. So that's why drawing the diagram, super important. So sine y over r. Where does the negative have to go? To the y or the r? It has to go to the y. R can't be negative. What if they would have given it to me like this? Sine theta equals 2 over negative 3. Would r be negative then because it's negative? No, what would you have to remember to do? Move the negative to the 2 because y can only be negative. R can't be. Okay, so that's another way they give you a trick. You try and use r to be negative. But r can't be negative. R is a distance. R is radius. It can't be negative. So you'd have to move that negative up here and make it like this one. Okay? So it's negative 2 and positive 3 for my r. I need to solve for x again. So x squared equals r squared minus y squared. X squared equals 9 minus 4. X squared equals 5. Square root, plus or minus. And because it's over there, x has to be negative root 5. What question do you think I'm going to give you? Which trig ratio would be the hardest? One where x is on the bottom. Why? and then you have to rationalize the denominator. So what option do I want? I could give you tan, because that's y over x, or I could give you secant, because that's r over x, because secant is the opposite of cos, right? So I'm going to do secant. So secant is r over x, so it's 3 over negative root 5, which I'm going to write as negative 3 over root 5, multiplied by root 5, and I'm going to get negative 3 root 5 over 5. You try the last one. We want the quadrant where cos is negative and where tan is negative. What quadrant is that? 2, because that's where sine is. The only thing that's positive there is sine. You did this last year. I promise you, you did these last year. The negative and positive. Cook extra rice. So negative 5 and 13. I have to solve for y. So y squared equals 13 squared minus negative 5 squared. Y squared equals 169 minus 25. Y squared equals 144. Square root of that is such a beautiful thing. Y equals plus or minus 12. Has to be positive, so it's 12. Honestly, when you don't get a square root, you're like the happiest little math person ever. You didn't realize you could get so much joy from a perfect square, really. Okay, I can ask you anything now. None of them have to be rationalized, right? The only thing I'm probably not going to ask you is secant, because secant is this flipped. You wouldn't have had to find the other side. So I'm going to make you find cosecant. So cosecant is the reciprocal of sine. Sine is sine your resume. So cosecant is going to be r over y. So 13 over 12. So this is what you do if you're given a trig ratio and you're asked for a trig ratio, right? They're going to make you find the third side. I just can't even imagine that on a diploma they'd make you just do the flip of it. Like, I just can't even see that happening. They'll make you find the third side and then give a trig ratio that involves it. Okay. Now, we've done this before. Honestly, if you have your unit circle, you're going to need your unit circle. You're going to need it handy, and you're going to need to be able to draw it. Okay? Now, on your unit circle, every coordinate is cos then sine. Some people remember it as Calgary Stampede. Cos then sine. Every coordinate. If you look on my unit circle up there, it's cos then sine. So if ever I ask you for just cos or sine, if I ask you for cos of any of the angles on that unit circle, you just give me the x value. If I ask you for sine of anything on that unit circle, you give me the y value. Now, if I give you cosecant, you're going to take the y value and flip it because it's just the reciprocal of sine. If I give you secant, you're going to take the x value and flip it. What if I give you cotan and tan? Well, on your formula sheet over here, it says that tan is sine over cos. So you're going to take whatever the y is on the unit circle and divide it by the x on the unit circle. So you'd be dividing fractions. When it's cotan, you take the x and divide it by the y, because the x is cos and the y is sine. So any trig ratio for any of the value off of that unit circle, I can ask you secant, cosecant, tan, cotan, sine, cosine, and you can pull it off that unit circle. Okay? So tan of 90. Off of your formula sheet, tan is sine divided by cos. So it's y divided by x, because sine is y. So we're going to do y divided by x at 90, because pi over 2 is 90. Your unit circle at 90, your point is 0 and 1, right? So we're going to do 1 over 0. What is 1 divided by 0? Undefined. You can't divide by 0. You can go 0 divided by 1, that's 0. 1 divided by 0 is undefined. On the tan graphs, you're going to see that an asymptote actually occurs there because it can't exist, right? Get 90. Cosecant is 7 pi over 6. Cosecant is what? The reciprocal of what? Sine or cos? Remember, it's always the opposite letter. So if it's cosecant, it's the reciprocal of sine. If it's secant, it's the reciprocal of cos. Okay? C's and S's don't ever go together. So 7 pi over 6. We go to our unit circle. It's the same spot. It's 210. Okay? I want the reciprocal of sine. The reciprocal of sine. Which is sine? X or Y? Y. So I go to Y, and it's negative a half, and I flip negative a half. What's negative a half flipped? What's negative a half flipped? Negative 2 over 1. Do I have to write 2 over 1? No. So it's just negative 2. So when they give you the trig ratio and the angle, they want the outside of the circle. They want the answer on the outside, right? If they give you the trig ratio and their theta is missing and they give you an answer, then they want the actual angle on the inside. If you're missing theta, you're missing an angle. If you're given this, you're missing the answer. Okay? Sine of negative 300. What coterminal angle is negative 300? 60. So can I write sine of 60 and get the same answer? Because it ends on the same terminal arm, right? I'm just giving you answers on the terminal arms. So at 60, what is y? Root 3 over 2. What if you went sine 60 and the moment, so when you go to press sine, you think, do I have to do radian or degree, whenever I press that thing. What if you went, okay, I need degrees because I'm putting in a degree, and you pressed degree and you went sine of 60? Would you be correct? No, because it asks for exact values. Now, if I turn this into a decimal, would it match that decimal?
Yes.
Yeah, it would. It's just that it wouldn't. It's just that it wouldn't be a exact value. It would actually match it. So you can check. You could check all of your answers by actually plugging it into your calculator, getting the decimal, and see if it matches. But these are exact values off your unit circle. They just, like, you don't have to check them. They're there, right? Secant is the flip of what? The reciprocal of what? Cos. Cos is x or y? X. So I want the x at 60. The x at 60 is a half, but that would be the answer to cos. So what would be the answer to secant? If it says exact value, most of the time you're pulling it off your unit circle, because that's where you're going to get your exact values from, right? If you're pulling a decimal, you're not getting exact value. Okay. Do you see these 8 questions here?
Oh, man.
Go. Cos of 150. So we need the x of 150, which is negative. What'd you get? He's not there. You're passing it to an imaginary person.
I know.
Sine of 315. X or y? Y. And at 315 is going to be root 2 over 2, but negative root 2 over 2. It's 45-degree reference angle. They're always root 2 over 2, which is sweet. Sine of negative 30. Negative 30 is coterminal with what? 330. So what's the y at 330? A half? Negative a half? Tan of 240. So 240. Tan. So we go to 240, and tan is sine divided by cos. So it's going to be negative root 3 over 2 divided by negative a half. When you divide fractions, what do you do? you multiply by the reciprocal. So you get negative root 3 over 2 times 2 over negative 1. Could I went negative 2 over 1? Yeah, same thing. The negatives cancel. Why is that? And tan is in the third quadrant. What's tan in the third quadrant? Positive. So they have to cancel. If they don't cancel, you messed up. The 2's cancel, the negatives cancel, and you're left with root 3. 480. What is that coterminal with? 120. So you subtract 360, right? So you go to 120. 120's y value, because it's tan, is root 3 over 2 divided by negative a half. Why is the end going to be negative? Our answer can be negative. Why is it going to be negative? Because it's tan in the second quadrant. What's tan in the second quadrant? Negative. So you should be able to even narrow down some of your multiple choice answers, correct? Just based on you should know what the sign should be in that quadrant. So we're going to get root 3 over 2 times negative 2 over 1, which is negative root 3. When you have this squared, when you have that squared in the middle, they write it like that, but if you went to go type it into your calculator, you'd actually have to write it as cos 225 squared. You'd have to go like this. You can't physically type the squared in the middle. And what would your calculator need to be in? What mode? Degrees, because you're typing in 225 degrees. We're not going to type that in because we want an exact value. But if we went to type it in, we'd have to do that. Okay? So cos 225. 225 falls in the third quadrant, so our answer is going to be negative. Is it going to be negative? Doesn't matter what the heck the answer was. We're squaring it, so it's always going to be positive in the end. So cos 225. 225 is negative root 2 over 2 because it's the x value. I square that. Square the negative, it goes away. Square the square root, it goes away. Square the 2, it becomes a 4. So my answer is a half. Like I said, I expected you not to be able to do those ones. Yeah. The next one, same thing, just more. Because I feel like everyone needs more practice. And these are in radians, which everyone needs more practice in. So sine of 5 pi over 3. 5 pi over 3 is 300 degrees. Sine is y, so it's negative root 3 over 2. Do you see how memorizing the unit circle saves time? Substantial amounts of time. If you don't, you're going to end up filling it in the end just by having to solve random questions all over the place. You go to 5 pi over 3, which is 300, and you take the y. Tan of 7 pi over 6. So you need tan is y divided by x. So it's going to be negative a half divided by, oops, negative root 3 over 2. So it's negative a half times negative 2 over root 3. And so I'm going to get 1 over root 3. What's the catch with that? You need to rationalize. So you're going to get root 3 over 3. Two pi over 3 is 120. So negative 2 pi over 3 would actually land you on 240. 4 pi over 3. So this is coterminal with cos 4 pi over 3. Could you take negative 2 pi over 3, convert it to degrees, find the coterminal angle, and do it? Yeah, absolutely. There's nothing stopping you from doing that. There's absolutely nothing. You're just trying to find the terminal arm so you can give me the x or y values or the division of those, right? So you can convert that directly to degrees, find the coterminal angle in degrees, and give me the answer. It's going to land on the same arm. You can do that. You don't have to keep it in radians. So 2 pi over 3 is negative 120. Negative 120 plus 360 is positive 240. So we're going to take the x value, which is negative a half. Which makes sense because cos in that quadrant is negative. Sine of negative pi. So that's sine of negative 180. Add 360 to that, that's sine of positive 180. This is coterminal angle. Sine is the y value. The y value at 180 is 0. Because 180 is flat. It's on the x-axis. What's your y value on the x-axis? Nothing. It didn't go up or down, right? Negative 5 pi over 3 is the same as 300. So it's going to be cos of negative 300. Sorry. And then the coterminal to that is cos of 60. Cos of 60 is the x at 60, which is a half. And then this one we're going to do tan. What's 2 pi over 3? 2 pi over 3 is 150? No, 120? All right, it's 60-degree reference angle. Tan of 120 squared. So we need to find the tan 120 first. Tan is y divided by x. If I just had cotan in there, I just do x divided by y, right? It's nothing much trickier. You just remember which ones you do. So y divided by x at 120 is going to be root 3 over 2 divided by negative a half, which is root 3 over 2 times negative 2 over 1, which is negative root 3, which makes sense because in that quadrant tan is negative, right? Are we done? People will say we're done. No, because we didn't square it yet. So tan of 120 is negative root 3. So I'm going to do negative root 3 squared is 3. Now, what if they don't give me questions off the unit circle? What if they just give me sine of 1.92? First off, is that radians or degrees? 1.92. Radians, why? It doesn't have a degree symbol. If it doesn't have a degree symbol, it's not degrees. It's the easiest way to tell. If it has a degree symbol, it's degrees. So, to determine the approximate value means you don't have to pull it off the unit circle. Probably can't pull it off your unit circle. Round answer to 4 decimal places. This is just testing if you know how the heck to change your calculator from degree to radian and radian to degree. If you press the mode button on your calculator, the mode button, it resets your calculator into radians no matter what. And you remember how your teachers used to stand at the front and it was grade 10 and 11 and they'd be like, make sure you put your calculator back into degree mode because it reset it into radian mode, or the teachers were nice and they reset it into degree mode for you, or you'd be super sad because you forgot to and you did your entire final in radian mode, got every answer wrong. That happens. So there's no such thing as you need to be one or the other. It doesn't matter if they reset it back to radians because you're going to be moving back and forth between the two. Okay? Now, if you convert your stuff to degrees, then most of the time you can keep it in degrees, but all your word problems, all the word problem graphs are going to have to be in radians. So you're never going to get completely around radians. Okay? So you're going to have to adapt. So, radians, because this is radians. So the first thing I'm going to do, I'm going to go to press the sign button. I'm going to be like, stop. Before I press that little button, I have to think, what mode do I need to be in, right? Because if I press those 3 buttons, or second of those 3 buttons, I need to be in this particular mode. So I need to be in radian mode. Yes, 1 second. So I'm going to go mode, and I'm going to make sure I'm in radians. Okay, it is. So then I can go second quit if I want, or you can be the person who presses clear thousands and thousands of times till it gets you out of whatever you're in, because that's usually everyone's go-to. They like hit clear like a bajillion times and hope it takes you out. clear buttons probably don't have actual words on them anymore because it gets hit more than any other button on the calculator. I've witnessed it, the vicious clear pushing buttons. It's like, just get me out of it a lot. Yeah, because it gets you to quit. It's a wonderful thing. Yeah, not the vicious clear button move, which most people do. Or they just start hitting it, or they turn it off. That happens sometimes too. Okay, so what we're going to do is we're going to go sine 1.92, 1.92. You can close the bracket if you want. Leave it open if you want. Doesn't matter. Press enter. Okay, 4 decimal places. It says. So I'm going to write decimal 9396. Do I need coterminal angles to punch these into your calculator? No. Coterminal angles you need to find a certain thing on your unit circle, but whatever. So I'm going to go tan negative 500 degrees. So what if I punch it in right now? I'm going to get an answer. An answer will be on your diploma. The answer will be completely wrong, but it will be there for you. They will have the Radian Mode oopsie on there. They will. I'm going to go mode. I'm going to go to degree. I'm going to hit enter. And I'm going to get out of this. I'm going to press tan negative 500. And I get 0.8391. Now, the reciprocal function conundrum. There is no button for that. Right? There is no button for secant. And if you're flipping out, think, I have no idea what I'm doing. When you resolve in that form, when you're almost ready to crumble, think, oh, right, I have a formula sheet. Maybe it can help me. So I go to my formula sheet, and my formula sheet says secant theta, or in this case, secant 85.4 degrees, is the same as 1 over cos of 85. Oh, yay! Type it in like that. That's all I got to do. Don't let it throw you off. People are like, I couldn't remember what to do. I'm like, your formula sheet, your formula sheet. So 1 divided by, and I can keep going because this one's in degrees, right? So cos 85.4. So 12.12 decimal 4690. 90 because the 9 bumps the 9 up to 0, bumps the 8 up to 9. Well, 9 up to 10 actually. Okay, cotan of 3. That's radians now, right? So my mode. Radian. Second quit. And I'm going to go 1 divided by tan of 3. Negative 7.015. Okay. We're going over one last thing. So what we've done today is I give you a trig ratio, you have to find another one, right? We draw it, we find our third side, we give our trig ratio. The other things we've done today are, I give you cosine, secant, cotan of an angle or a radian, and I want the answer off the outside of the unit circle. So what's the other thing I can do? I can give you the answer off the outside of the unit circle and ask you for the angle or the radian measure, like the degree or the radian measure. So we're going to do that today. The following day, we're going to do ones that you can't get the answer off the unit circle. So I give you the answer, but the answer isn't one off the unit circle. You have to solve it a different way. You did it last year too. Everything we went over to this so far is all from last year, except for radian measures, brand new to you, and coterminal angles are brand new to you. But being able to solve any of this was from last year. Being able to do what we just did at the beginning, getting the extra trig ratio, was from last year. Pulling stuff off the unit circle, last year. All of this is from last year. We're just adding radian measure to it and coterminal angle. Okay? So last thing. Nope. This is that page you have.
Yes.
So all of the previous questions were cos of an angle, and I gave you this. We had to find this, right? We defined the angle, the answer, sorry. Now I'm giving you the answer, and I'm asking for the angle. Now, whatever the domain is restricted in, you guys, You have to put your answers in. If it's restricted in degrees, your answers have to be in degrees. If it's restricted into radians, your answer has to be in radians. If it's restricted between 0 and 360, your answer has to be between 0 and 360. Okay? So what do I always do? I used to make people draw the different things. Now I always say, find the angle between 0 and 360, or 0 and 2 pi, whatever it may be, and then find the coterminal angles around it and see if they fit in that domain. It's just the easiest to find if you find the ones that fall between 0 and 360 first, or 0 and 2 pi. Okay. So we want negative 1 over root 2. What's negative 1 over root 2 the same as? Negative root 2 over 2. Where's cos negative? Quadrants 2 and 3. So look where x is negative root 2 over 2. Where's x negative root 2 over 2 on your unit circle? $135 and 225. Remember, if you have a full 4-quadrant deal, you're going to get 2 answers because cos is negative in 2 places. Cos is positive in 2 places. Okay? So theta, because we're solving for this, equals 135 degrees and 225 degrees. What if this is between 0 and 2 pi? Could I give that answer? No, that's degrees. It would have to be in radians. But our domain was in degrees, so we're good. Sine theta equals negative root 3 over 2. Negative root 3 over 2. Sine is negative in quadrants 3 and 4. Quadrants 3 and 4. We want between 0 and 2 pi. 0 and 2 pi is the unit circle, right? It's just the radian degree measure. So where is y, because y is sine, where is y negative root 3 over 2? At the 60-degree reference angles, right? So at 4 pi over 3 and 5 pi over 3. Now, tan equals 1. The only place that tan equals 1 are negative ones, and keep this in your head because this is very important. Tan equals 1 and negative 1's at 45-degree reference angles. Why would that be? Well, tan is y divided by x, correct? What's y and x at 45-degree angles? Root 2 over 2 and root 2 over 2. When you divide root 2 over 2 by root 2 over 2, when you divide something by the exact same thing, what do you get? 1. 3 divided by 3, 1. 4 divided by 4, 1. So root 2 over 2 divided by root 2 over 2 is 1. So tan is going to be positive 1 in the positive quadrants. So 3 and 1. Tan is going to be negative 1 in the negative quadrants. 2 and 4, right? So we want positive 1. So tan is positive at these two. Correct? So we can do this in degrees if you want first. Most people do. So this is at 45 and 225. However, my domain is restricted from negative 180 degrees to 180 degrees. Yes, the answer is in radians. So we're going to have to convert at the end? Yes. Does that matter? Do you have to be stuck in radians and cry a lot and not get the right answer? No. If you can't deal with radians, that's fine. Do degrees and convert back. That's okay. I don't mind. So which of these angles actually fits in that domain? Between negative 180 and 180. 45. 225 is outside of 180. It's like here on the number line, right? 45 fits in here, so that's good. So we have 1. Now we have to check if this one, if I find the coterminal to it, maybe it fits as well. Well, if I add 360, I'm getting bigger. That's not going to be inside. But if I subtract 360, what do I get? Negative 135. Does that fit in the domain? Yeah. So theta equals 45 and 135, which is great, but I can't stop there. Why? My domain was in, so my answer needs to be in So I just have to convert at the end. How do I convert quickly by radians? Divide by 180 and add a pi. Right? So I do all the unit circle quickly, divide by 180 and add the pi to the top. So if I go 45 divided by 180, I'm going to get 1/4. So that's pi over 4. 135 divided by 180 is 3 pi over 4. At this point, if you wanted to, you could go, but what does this have to be? Sorry, negative. I didn't mean to put a negative sign there. Negative 3 pi over 4. Where is cos 0? Where is x 0? Where would x be 0 in the unit circle? Nope, that's where x is 1 and negative 1, because I have to come out like this. Where's x 0? Well, it's where it doesn't move at all. Still here and here. 90 and 270. Okay? This is restricted between negative 180 and 360. And you're telling me 90 and 270. Do those fit in there? Yes, they do. Do any coterminal angles also fit in there, though? We have to subtract 360 and see. 90 minus 360 is what? Negative 270. Does that fit in there? No, it's too low. 270 minus 360. Negative 90. Does that fit in there? Yeah. So we also have that too. So plus or minus 90. So the 90 and the 270 did fit, but I had to keep going, right? Because they gave me a bigger domain. So we're going to get plus or minus pi over 2 and 3 pi over 2. And we'll leave that one till the following day where we're going to do these ones that don't fall in the units. Well, that one does, but